We are shifting gears a little bit. We have talked about space, but now we have 3 space providers that are going to come up talking about big sats, small sats, red sats, blue sats, cat in the sats, all sorts of stuff. And I'm really not going to bother to introduce them because I think they introduce themselves well. So we're going to start with Chance from BlackSky. Chance Thomas, give him a round of applause.
Good intro there, right on.
Way to do it, all right.
All right, good afternoon. So I'm joining you today to talk partially about the satellite offering from BlackSky and partially also on our persistent global awareness as a service offering. So what we aim to do ultimately is to form a nexus for geospatial intelligence, opening up the realm to those who may be on the novice end and work our way all the way up through experts who spent their careers in GEOINT. In this case, we've got both the satellites that we'll talk about in some more detail later, but we'll start off with some context as well. So I want to make sure we talk a bit about the platform. Now, BlackSky as a constellation sits in that much larger GEOINT environment that we're referencing. So there is a platform offering that covers a greater deal than just satellites alone. And that involves both the analytics that works on images, on social media, on traditional media, and sources of other sorts. And then there's also traditional satellite data. So from our partner network, and then also from the BlackSky satellites themselves that you'll hear more about in a bit. And analytics as well has a similar structure. We have both the internal offering from BlackSky, the analytics that we are working on, processing for images and content, but also the external material, expertise built outside in companies and government that can be rolled in easily in a plug-and-play format. Now, as part of the hardware, let's cover that first, and then we'll step back into the platform for a minute. We've got both our Pathfinder program, which is the experimental set of satellites launched in September of 2016. And we've operated those to validate our engineering procedures and our ground procedures as well. And then you probably will have heard of the Global series, and those satellites are in final integration now and are preparing for launch here at the end of the year. So we'll cover that hardware offering in a bit. It's backed up also by a ground station network though. So that allows us to address the issues of cost and timeliness and volume of data via the satellites, but also to get that to you quickly, right? The ground station network complementing the satellite constellation, we end up with much more timely delivery on the order of minutes, not days. So to step back just for a moment, I want to give you an introduction to that broader platform and how we fit into GEOINT as a whole. So I've taken what was formerly a complex slide and brought it just down to 4 steps, 4 sectors of the GEOINT cycle. Right, phase 1, we ingest the data, and then we enrich through parsing algorithms and filtering. We move then to step 2, which is to allow the user to set up monitoring with the themes and content of interest to them. And so that covers, moving into step 2 covers the ability to specify interest in conflict, interest in disease outbreaks, and other very specific sectors. And it also allows one to focus in on certain sources or to combine sources. So whether it's social media or traditional news media or satellite imagery, for instance, to determine which ones are most critical to the mission at hand. And then also to specify interest by region or by asset. So if you need to upload a set of embassies and consulates, for instance, and be able to alert off of them when your incident occurs within a certain radius of that location. That also is part of that offering. We move up to part 3 in that traditional cycle, and that is to alert and to analyze. So we deliver the data, both the satellite material and this open source intel content to the user, allowing them, whether they're online or not, to be notified of an incident relevant to them, and then to move from that step into additional correlation, into annotation, and eventually into export and action. And that's what you see up there in step 4, taking action on satellite data. So that can be a manual process in which the user wants to export either technically or casually the material they've discovered and annotated in the platform, or it could be satellite-based, either through the tasking of new images manually, retrieval of archive material that's linked to the user, or through the automated tasking of satellites through thresholding. So here essentially we can take these processes running in the background in the cloud and allow them to become decision-making entities to determine when and where to take satellite images. So these are broken down into two principal offerings, and I'll just give some brief context on each of those. So the first is known as BlackSky Events, and that provides most of what we talked about in that intelligence cycle right there. So initially, the monitoring and the alerting, customizable again by site, theme, which actor or source or organization is involved in the event, and then also the time span if you're seeking to compare violence from one month to the next, or disease outbreaks from 2 years ago versus this year. It also allows you to move into that analysis phase, again, to explore the material that's been discovered by the algorithms, to discover new material, to correlate that information, and then to pursue some of the analytics that are functioning in the background inside the application. And finally, then to move on to the actions, which could be, as we mentioned, to assemble reports or to share and export data. Now, briefly, there's a view of data posted on a map, allowing the user then to engage with a variety of visualizations and content levels with what's been discovered, either in the background or what they've correlated on their own. The data sets are growing. We talked about media. We talked about both social and traditional media. We talked about satellite images, but there are also physical sensor networks and open source databases. So what you see here is AIS data. So it's posted over a series of months, ship locations, so you can see the specific regions of shipping channels in Southeast Asia. And the platform is built then to engage with a variety of inputs in a plug-and-play format, so that if there's proprietary material from a particular user that needs to be integrated and worked directly into the core of this analytical capability, that can be done with ease. As an example, this was last night's attack in London. We're able to call back within a matter of minutes text data, images, again, parsed through machine learning, both image processing, trying to detect what kinds of images out of the thousands being posted in news and social media are relevant, and then also text searching, pulling out tags, who's involved, which people are reporting on the event, which people are involved in the event, and estimating all along by correlating between multiple sites the exact location of the event. That second offering then is Spectra, which allows us to dig in closer to the hardware itself, closer to satellite networks, both from BlackSky and from our partner providers. This allows two principal capabilities. One is acquisition, the ability to dig through our archive and the archives of our partners, and then also to do immediate tasking. So if you want an image from anywhere in the globe, from any provider in our network, that can be done in a matter of just a few clicks. So after you track that through order and delivery, we hit the exploitation phase, where the user can retrieve that material in full resolution, stream it in to minimize the overall throughput they may need so that they can access this data in the field with a modest amount of connectivity, and then also apply analytics inside the application so that some baseline change detection, feature extraction, and annotation can be completed there in an automated fashion and then exported for later use. So now some frames from that as well, from our archive search, from our tasking capability, and from analytics of imaging trends. All right, down to the hardware. I won't deny you satellites today. So let's talk about the constellation. So you've got here a schematic of 60 satellites. We're intending to launch these satellites in waves of 20 as we progress out, reaching a carrying capacity in about 2020 of 60 satellites total. So with these capabilities, we're able to deliver on a number of factors, and I'll enumerate those in a minute. But what's up on screen is just a revisit capability globally. And this is baselined with two simple orbits, sun-synchronous and mid-latitude. And BlackSky intends, as you'll see in a bit, to insert our satellites into both of those orbital types, allowing us to access with great frequency the most populated areas of the globe, but also to ensure near total coverage in a matter of hours or minutes. So the core benefits of the constellation itself reflects first what you saw on the last slide, which is the rapid revisit, the capacity to do intra-hour collects, right? We're looking down to 20 to 40-minute revisits in particular locations. But it's not just about that. That's a new capability, but we have to do more. So with the benefits of the small satellite revolution and COTS products we are able to integrate into the satellite, we move into a much lower cost offering. So we're able to give you this new capability with the capacity to derive new information from much more frequent satellite collections and to do it at a much more reasonable cost. We do that again through the benefits of the small satellite revolution on the economics of cost in satellite components, but also through vertical integration in our larger parent company, Spaceflight Industries. Now, the third principal benefit that we look to provide is ease of access, and that's reflected on those earlier slides with the platform. The capacity to determine either automatically with BlackSky events or through your own processes that you need to collect imagery from a sensor. Perhaps it's remote sensing from one of our satellites or someone else's, perhaps it's a ground sensor, but to be able to log in from anywhere and place that order in a matter of seconds. So we allow integration both into the platform for us and our partners, plus API access to make this easy on bulk scale. And then finally, there's a fourth one here that I like to toss in, and that is our responsiveness. So we can talk all day about rapid revisit, but if it takes me 2 days to deliver the 10 frames that I picked up a while ago, it limits the value of that information. What we aim to do, again, by combining a broad ground station network with a large satellite constellation, is to provide that global access with a responsiveness that is much improved over current offerings. So then that global access can bring us down to a place where our average return time for an order anywhere in the globe, from the moment you click on the interface to the moment that data is returned to your account, is about 90 minutes, and we can achieve that for less than $100. So I can talk to you a little bit to end with the status of our Pathfinder and global programs. So there's an image here on screen of Pathfinder 1, which was built and tested last year and launched at the end of September. So on the 26th, we headed into orbit, and on our first pass, we received signal from the spacecraft. Within a few days, checkout processes had progressed to the rate, to the position where we were able to bring images down from the satellite. And in fact, within about 4.5 days, we were able to demonstrate full stressed capabilities on the system. So to explain that, I'll say the scenario that we wanted to test was the combination of the ground station and satellite systems and the automation that would be required to deliver an image as quickly as we're talking about, from click to delivery in 90 minutes on average. So to do that, what we did was uplink a command over one of our ground stations in Alaska, sailed across the Pacific, and that's about 25 minutes later that we slewed over, took an image over Australia, and then slewed immediately over to our New Zealand ground station, downlinked that, processed it, and then delivered it back to our operations center. All of that in less than 30 minutes, all of that about halfway through the first week in operations with a new ops team, a new satellite, and a new company. So from the test satellite, I can provide a series of images now over military bases, over civilian airfields, over a North Korean, both military, civilian airbase and missile launch site, and over airfields and other locations in China and beyond, along with many other shots you'll find on our website. So the next steps for us is to continue now with the global series of satellites, more capable, more effective, and more able to deliver on the mission that I've described than the experimental birds we sent up last year. So now, starting here at the end of the year, we'll deploy at least our first global satellite and then continue with waves of deployments in 2018. Following on that, we move into the standard deployment phase of 20 satellites per year until, again, we hit that carrying capacity at 60 satellites. As part of that, we're implementing near complete automation to minimize the delivery time and maximize the reliability of the system. And then we will go live with global data in the platform at the end of the year. Along with that, of course, we have ongoing development projects for future payloads and bus capabilities to push us beyond the global series into our new generation of satellites capable of higher resolution imaging and even more impressive output. So then, through the combination of that hardware and the constellation, the new capabilities, taking advantage of lower cost, better revisit, better capabilities, and combining that with the accessibility of the events and spectra offering online so anyone can access anytime, we hope ultimately to harness these various elements of both the small satellite revolution and of the expanding and emerging capabilities in the GEOINT sphere, right? So it's both space and cyberspace, to combine those to create something that in the end is more effective for our civil use cases, our commercial use cases, our military use cases, and beyond. So I thank you for your time, and we will see you at the booth.
Great job. Thank you. So the director of NGA, would you like to stand up and just stand up and wave to everybody, Robert? Please, Mr. Director. Round of applause. Excellent. When the director used to talk, I could say a year or two ago, about the small sat revolution, used the term darkening skies. And we were trying to remember, you've changed your vocabulary. What are you using now? Breaking vision? Brightening vision, because we're no longer darkening the skies. Thank you. We're going to keep on going, not darkening the skies. We just saw 60 satellites that are going to go up in orbit. Our next speaker will be talking about considerably more, not just about his company, but from a number of different corporate strategies that are being deployed in space. This speaker is one of the co-founders. Well, I'll say first he was worked at NASA for a number of years during their early forays into small sats, and then moved into the private sector as a co-founder of Planet Labs. Please give a round of applause to Robbie Schindler.
Thanks, Chris. All right, good afternoon, everyone. In my talk today, I actually wanted to talk more about the trends of what's happening in space, as well as its impact then for geospatial, for our community. So I'm actually going to go through about 5 trends in space and 5 in Earth observation, and I give examples of how we're seeing a bit of this future today already. Most of the examples are from my company, Planet, which I co-founded about 6 years ago, but it's not just Planet that's doing this. There are many examples that are happening. We've heard from some earlier today. We will on the panel later as well. And it really is an exciting time. I mean, we are at the midst of a revolution that's happening in the aerospace community, and that's my background. I came to the GEOINT community spending my time at NASA building spacecraft. So, and a little bit about Planet, because I'm not going to go into too much detail about it. We are about 430 people. We operate over 150 satellites in space. We have enough spacecraft in space that when fully commissioned at the end of the month, we'll be able to image the whole world every day. And most recently, about 2 months ago, we welcomed the Skybox team, the Terabella team, into Planet. So that also brings about 7 sub-meter resolution satellites into our constellation. But with that, I'm going to start about talking through 5 trends in space. First one is launch. Launch is the largest barrier to innovation in our industry by far. It is a broken problem. It still is broken, but there's a lot of unique things that are happening today that actually make it possible. The first one is this. This is developed, it's called a 3U form factor, and it's developed by a company called ISIS, which stands for the Innovative Solutions in Space, based in the Netherlands, that ISIS. And they do secondary payloads so that people don't have to buy a whole rocket to get access to space. And this has been a huge revolution, at least for us, to be able to get access to space very frequently. Not only that, but the International Space Station is being used as a scientific testbed to actually deploy satellites into space. It's more like a launching platform. And here you can see 2 of our small satellites. These are called Doves, that are about 5 kilograms each, being deployed from this orbiting platform. And with the secondary payloads, you can get access to a more operational orbit. And in this one, this shows about 3 months ago in India, 108 satellites were launched on one rocket. And that's a world record by about 3 times. And Planet, we had 88 satellites on there. And you can see them, this is sped up a little bit, but you can see 88 satellites being deployed into space. So this is happening, this is real, and there's a lot more of this stuff that's actually coming. And if we can do this as a small, relatively small company, nations are doing this, large companies are doing this, and we're actually seeing that happen. But it's still not solving the problem. And the thing that I think is going to absolutely transform our industry is nanolaunch. And something happened last week, I guess, a week and a half ago, out of New Zealand. Rocket Lab did their first test launch. This is for 150 kilogram capacity in order to go to space. And when this actually works, we'll have brand new overhead architectures. So that's launch. And anything in space, you either get access to space with launch, or then it's the sensors that you put in space. And the sensor revolution that we have on the Earth is beginning to get into space. At Planet, this is something that we actually took from the university community, which were CubeSats, and then began to stuff in a lot of capacity using the chips and components from the sensor revolution that's happening in space to then make it work in the aerospace environment. We've gone through so many iterations of our spacecraft that we now have a power positive satellite. Here you can see over the course of 2 years just some of the increases that happened across the same exact mass, the same exact volume, same exact power that you can do when you really get to know the end-to-end system and do things of more of a capabilities-based approach rather than starting from the end requirements that you absolutely want and to bring them down. So we call that agile aerospace as an example of sensor revolution coming into space. So when you bring these 2 things together, what we're going to see in the future architectures for the 21st century is really disaggregated and diversified architectures. And in the security and military community, this actually helps a lot. This gives us resilience, this gives us reconstitution. If we're able to actually marry small launch with very, very low cost and very, very capable spacecraft, then that also means that we could actually use that as a bit of a deterrent from not having an adversary that's doing an asymmetric event in space to take out a very, very large billion-dollar asset. And so at Planet here, you can see these are 88 of our satellites, 4 in each one of those boxes getting ready to go into space. We've learned how to mass manufacture these spacecraft. You can build 20 of them in a week right now. This actually shows our reference mission that we call Mission 1, which is 100 of those small satellites in a sun-synchronous orbit, creating a line scanner for the planet. All of those spacecraft are now in space, and we get the whole world every about 3 days right now. And then as they are fully distributed along track, we'll get everywhere every day in the summertime. Combine that with some rapid eye satellites that we have in space and some SkySats, you begin to get an interesting ConOps, where you can use one for one purpose and use one for another purpose, but then when you put a lot of machine learning to that and automation against that, take the human out of the loop, you could actually do automated tipping and queuing and a variety of activities. So I'm very, very excited about that. 2 more things that are happening in space that we really need to always keep an eye on. One is space debris and the need for open space situational awareness. There is a trend where near-Earth space we're getting mega constellations, at least on paper, and people are getting a lot of money in order to build these constellations for telecommunications and for remote sensing. But in order for that to actually really, really work and become societal infrastructure for our planet, we need to be able to take the rules of the road that we have on land, in air, on ocean, and bring them into space. And if we don't do that, then we're going to have a really, really big challenge. So there are a lot of space debris in low Earth orbit. The majority of it is in this particular orbit around 800 kilometers. But they're dead. Most of the satellites there are dead, so you have to actually avoid it. And we haven't gotten to a point yet in the community to actually make that more open for us to have rules of the road in order to get toward a space traffic management system just like an air traffic management system. So that's one of, I think, the new policy items that we have to actually take on together, both as industry as well as commercial, or as well as in government. And the last trend, I think, in space is really the way that the government's role is shifting, where we can see that the government is beginning to buy a commercial service, buy the outcome rather than the process, and then take their resources and then focus on things that are harder out, that give them the asymmetric advantage that they're actually looking for. A good example of that is with SpaceX. NASA did this in 2005, I believe, with SpaceX for the commercial orbital transportation service to go and service the International Space Station. And today, we see what SpaceX has actually done. They've continued to invest into technology, into their capability to get to reusability, to get to manned spacecraft. And I could also say the same thing for Director Cardillo and his team over at NGA, where they've recognized that this is happening and trying to think about how do you buy this as a service? How do you buy something that is commercial and actually bring it into the operational workflow? And then working with the folks over at Source, they're encouraging people to get on the GSA schedule in order to buy this commoditized product. So there are signals of this that are actually working really, really quite well. So those are the trends in space. I want to also talk about 5 trends or observations that I've had as I've gotten to know your community over the last 5 years in Earth observation. So the first one is around pixels. And just about every single pixel means something to everyone. And so what I mean by that is, if we take a look at the contested areas in the South China Sea, here's Lad Reef. You can see some dredging that's happening by the Vietnamese. And that's clearly there for maritime domain awareness. But then you have a researcher like Greg Asner from Stanford who's using these same exact data to understand what that's doing to the ecosystem, what that's doing to the coral reefs in the South China Sea. So every pixel can mean something to everybody. And in fact, I go even further into that in order to think about this from the very beginning of a new mission, which is, if you just focus on the military point of view or just focus on the commercial point of view or the science, then you can actually not have them be mutually reinforcing. And that there is a sweet spot in there. If you take a look at our reference mission at Planet, right, it's a land monitoring mission. It's just seeing change over time. That has a tremendous amount of scientific utility. From a commercial standpoint, it's measuring economic flows and stocks on the planet. And from a civil or from a military standpoint, it gives you needed information for broad area surveillance for patterns of life analysis and serendipitous collections. So it's the same mission that can be used for all of those purposes. Second is what I would call web geo, and we've already heard from this from the panels beforehand around the commoditization of storage and compute, being able to spin up a supercomputer when you need it, but then also the trend toward open algorithms and really, really sharing a lot of the computer vision and the machine learning algorithms on top of all of that data. And with that, everyone who's actually processing their own satellite imagery, you're essentially creating a geospatial data pipeline. And so that is the core product that we're building at Planet, which is a platform for analytics. We're also working to try to bring the innovators from decision science and machine learning communities to bear using Kaggle in order to actually try to detect deforestation with labeled training data over the Amazon. And in fact, if you also go back to this same example, when you take a look at it from a computer vision standpoint, you can go ahead and identify in near infrared the dredging, or you can identify the ships. You can count the ships from day to day to day. And the same thing not only from ships, but for planes. And you can begin to get these things actually as a service, as a monitoring capability. The third one is that you need the content. Content feeds the machine learning. It wants more data, it wants more labeled data and trained data, but over time, if you're collecting a whole bunch of data, you will get better models. You can go back and rerun the world, and you can get to a point where you really get near real-time information around what's happening. Here's a bit of an animation that shows what our journey has been at Planet with respect to launching earlier satellites that were less capable, back in October 2015, and then over the course of 2 years, launching more satellites and very capable satellites, getting to the point of the launch that I just showed before, being able to see that this is 150 million square kilometers, which is about the land area of the Earth every day. And with that, you get toward, again, understanding patterns of life, get toward predictive analytics, and it all drives for people to make better decisions. And it's all derived from Earth observation data, but it really is the signal that people are actually looking for in order to better augment what they're doing. So, it seems that where we are today is the sensor revolution is happening. We're beginning to actually bring it into at the speed of computers and machines. Pretty soon, it's going to get into a workflow where it's part of our daily lives, and that then will actually allow for us to act now with better information. And then when you have really sophisticated models, and we're seeing indication of pilot projects of that are happening in the community, you get toward the predictive analytics. On the business side of things, I want to mention 2 things on that. One is our industry really focuses a lot on grants and projects rather than building products and businesses. And that's really the revolution, I think, that you're seeing from a number of people that are out there. And in fact, if you take a look at the market, or before I get to that, here's a good example of that. This is a partner that we have in Canada, Farmers Edge. Well, first of all, agriculture is our largest market. It's not federal, it's ag. It's because they're a very technology-forward organization. They've been consuming geospatial data for a long time as part of the Precision Ag organization, and they're building these into products that are scalable and really taking off in that way. So if you take a look at the traditional market of Earth observation, it is about $5 billion market, which is tiny in the scheme of things. And that's working on projects mainly for institutional organizations, about 80% of it. But really, if we begin to think about it as information feeds to allow people to make better decisions, we're really in the business-to-business information services market, which is much larger. And that's really the big story, I think, that's happening, that the transition is going to happen over the next 5 years. The last thing I want to talk about is also, why does this matter? Like, how can this actually impact our planet in order for us to live a little bit more sustainably on it? And and I think that there are a number of things that could actually happen. So the concept of externalities are things that aren't measured in the global economy. There is a potential ability to get insights and indicators to bring externalities actually into the global market. And that allows for us to live more sustainably, but then also grow the market because you're actually valuing more things. So there's a simple framework that goes through this that we have at Planet that we do with our impact partners, both in foundations as well as in development organizations, around collecting the information that we have, getting interesting insights in that, bringing the community together to form an indicator that then is fungible, that allows for the financial industry to then create a new instrument on top of that. And that's when we're actually talking about thinking through how we can take this sensor revolution, this transparent planet, and allow for people to then make better decisions. And a good example of that is carbon. So we are working with a couple of partners on being able to go through and measure carbon loss over time. Here you can see in the Amazon how much carbon is taken away as this actually moves forward. So quickly, in summary, in space, so important, it's up there twice. Launch is still the biggest problem that we have. Sensors, the direction where that's going is fantastic. There's a lot of private investment in that, so I think that we're actually good relatively there. But there's quite a bit that we need to do as a community with government and with industry, with new overhead architectures to make sure that it's resilient, with open SSA and space traffic management, as well as procurement reform and so forth, as we actually encourage their third leg of the stool from civil and military being commercial to be stronger and part of a 21st century aerospace ecosystem. Then on the Earth observation side, to really make sure that we're thinking through the other players that could actually be part of the mission, and to come up with an economic business model that then allows for you to provide that service over and over and over again and increase the utility of the service. So thank you very much. I'm here for the rest of the time. We don't have a booth, but we will be around. Have a good conference.
Thanks, brother. So our last speaker for this session will be from DigitalGlobe. DigitalGlobe's gone through I guess a series of acquisitions over the past year. And we are fortunate to have the new Chief Technology Officer from DigitalGlobe, Radiant. Please give a warm round of applause to Abe Usher. Do it.
January 15th, 1991. Franklin Meeks put out a statement to the press that a military event was imminent. Mr. Meeks was Domino's Pizza franchise owner in the DC area, and unofficially was considered the pizza czar for our nation's capital. On January 16th, his message was picked up by the Chicago Herald-Tribune. According to Mr. Meeks, the pizza index was elevated due to increased pizza delivery in the evening to the White House, Pentagon, and State Department. Mr. Meeks was quoted as saying, "The increase in pizza orders at key government buildings after 10 p.m. is very unusual." You can see this is what the pizza delivery in the evening might have looked like ordinarily in 1991. And the week of 11 to 16 January looks something like this, where there was increased pizza delivery at the White House, Pentagon, and other areas in DC. What does pizza delivery have to do with the military? Well, in this case, pizza delivery was a proxy variable for national security planning. The day after the article, 17 January, Operation Desert Storm Air Campaign started. My name is Abe Usher, and today I'm going to discuss how this increase in available satellite imagery from space creates new opportunities. I'll explore new proxy variables from space and cyberspace, new ways of perceiving objects, and some predictions. First, a definition: proxy variable, data that serves in place of unobservable or immeasurable variables. A simple example of something that is immeasurable, if we looked at Foursquare in New York City, we probably couldn't tell exactly what the temperature is by the comments. However, the CTO of Foursquare, Andrew Hogue, identified a correlation. For every 2% increase in Foursquare check-ins at ice cream shops, there's a linear correlation with an increase of 2 degrees in temperature. Another example from social media, looking at geolocated tweets over Tempe, Arizona. The region of the city that has the most mentions of the word coffee in a 15-minute period happens to be the location of a Starbucks. In this graph, we see tourist activity demonstrated by a thematic map where green, yellow, orange, and red define the density of activity by tourists on Twitter. Around the nation's capital and the perimeter, the tall red bars are places where tourists are getting on the metro and waiting for their train, getting on Twitter. And the big blob of red in the middle, that's the National Mall with the Smithsonian and other national monuments. Moving from cyberspace into outer space, I think the canonical example of proxy variables in our industry is counting cars in parking lots. Earlier today, you heard Matt from Audible Insight talk about using the number of cars in a parking lot as a correlation to economic activity at stores like JCPenney's. Similarly, if we can do that with a car parking lot, looking at seaports, we can examine the number and type of shipping containers to understand economic activity. In this photo, you can see Puerto Cabello in Venezuela in 2013, where there's a significant amount of economic activity and things going on. Fast forward 3 years, and what you have is a virtual asphalt graveyard with no activity, painting a stark picture of the current economic situation in Venezuela today. If we can use cars and ships, we can certainly look at armored vehicles as a proxy for military posture. But what happens if we're interested in these proxy variables and we actually need to count objects in a photo? If we were going to look at this overhead image of a parking lot, what if we needed to count every car? Let's count them together. 1, 2, 3, 4, 5, 6, 7. Okay, we don't actually want to count all the cars manually. There are some people that enjoy this kind of activity, but we'd rather bring in some automation to do these types of things. So that brings us to perception by computers. Computer vision is a field that relates to understanding, acquiring, processing, analyzing digital images. In the old days of computer vision, the state of the art was optical character recognition. We could take things like license plates and take an image and turn it into a string of characters. But that was about as good as it got. If we wanted to do something more advanced, we needed human experts. So for a long time, our philosophy of knowledge has related to people. And by way of example, in 2005, NPR interviewed a hip-hop artist, Ice-T, with the question, how can you tell the difference between a legit hip-hop artist and someone who just gets up on stage and rhymes? His profound answer, game knows game, baby. And by that, of course, he meant if you have subject matter expertise in a particular domain, you're capable of making expert judgments using contextual information. So for a long time, we've depended on human experts to do things. But recently, this human subject matter expertise model has changed. Around 2015, deep learning and machine learning matured enough that we can actually give computers an element of human subject matter expertise. We can train them to understand questions like, what kind of scene is this? How many cars are there? Where's Waldo? I know some of you are looking to find where Waldo is. He's actually right there. So I decided to take some of my recent vacation photos and feed them to commercially available machine learning algorithms. Taking this image and giving it to Google Cloud Vision found terms like firearms, weapon, shooting range, soldier. Similarly, Amazon's online APIs found things like person, shooting range. Impressively, Microsoft Azure's summary of the photo, a man holding a gun. Just for fun, I decided to give these algorithms a slightly fuzzier, lower resolution version of the photo, and I got a person riding a surfboard with 65% accuracy. So clearly, the technology is not perfect, but it's maturing. Let's see here. So if we can do this for on-the-ground photos, why not do this with video? So I went out and grabbed an off-the-shelf machine learning algorithm called YOLO and looked at its performance against the James Bond film Skyfall. Let's roll the video clip. This technology has matured enough that we can actually detect objects in faster than real time. What you're looking at here is an example of an overhead machine learning model from space identifying swimming pools. In order to advance the industry, DigitalGlobe, working with CosmicWorks and NVIDIA with some insight from NGA has an initiative called SpaceNet, where we've actually put into the public domain pre-labeled overhead imagery models so that other people can create their own machine learning models for identifying objects in imagery. For those that don't want to build their own model, we also have an application called GBDX, the Geospatial Big Data Platform. This provides point-and-click easy access to machine learning models against DigitalGlobe imagery and imagery from other providers. Okay, a couple of predictions. You've been hearing all day about the volume of remote sensing data. It's only going to increase in the future. In order to rise to the growing volume of data, we need additional automation and machine learning to consume the data. As we combine machine learning with this additional data, we're going to find new proxy variables and advance our ability to create probabilistic and deterministic models to understand human behavior. If you're interested in learning more about machine learning at DigitalGlobe, please join us at our booth 1139. Thank you.